I'd like you to start with this warm-up problem today. Press pause on your video. When you're ready for the answer, press play again. You can see that I knew that secant of theta was 6 over 5 and tangent was negative. Secant is positive in quadrants 1 and 2. Tangent's negative in secant's positive in quadrants 1 and 4. Tangent is negative in quadrants 2 and 4. Therefore, my angle must be in quadrant 4. I drew in my angle. I know secant is the reciprocal of cosine, so it is the hypotenuse over the adjacent side. So I made 6 my hypotenuse and 5 my adjacent side, and used Pythagorean theorem to solve for y. Y is negative since it is in the fourth quadrant. Then I simply used my knowledge of what each of my trig functions is in terms of x, y, and r to find sine, cosine, tangent, cosecant, and cotangent. So sine is y over r, cosine is x over r, tangent's y over x, cosecant is r over y, cotangent is x over y. And again, you always have to make sure that you simplify your answer, and sometimes that means that you need to rationalize the denominator. Next, you need to find tangent of 23 pi over 6. This was over 2 pi, so I first found my coterminal angle by subtracting 2 pi. So I subtracted 12 pi over 6 from 23 pi over 6, and I got 11 pi over 6. That is in quadrant 4. So in quadrant 4, I was able to find my reference angle by doing 2 pi subtracting 11 pi over 6. That's where my angle is. And 2 pi is 12 pi over 6. If I subtract 11 pi over 6, I find my reference angle is pi over 6. Now, looking in the first quadrant at my reference angle, tangent of pi over 6, again, is y over x. At pi over 6 on my unit circle, I know that x is the square root of 3 over 2, y is 1/2, so it's 1/2 over the square root of 3 over 2, and then I simplify to get square root of 3 over 3. Now, since it's in the fourth quadrant, I know tangent's negative there, so tangent must be negative root 3 over 3. Very important to remember this process because we are going to continue to use that today. Now, we are going to find trig function values and angles using our calculator when our angles don't fall very nicely on the unit circle. So you have to pull out your calculator. And the first two of these problems, B and C, are in degree mode. C and D are in radian mode. So you have to make sure to press mode, the mode button on your calculator, and make sure that it agrees with the angle you're typing in. So A and B are in degree mode, so I highlighted degree. And we will type cosine of 15.3. 0.3. And that is 0.9646 rounded. Now, secant is not directly on the calculator. I do know that it's the reciprocal of cosine, so I have to write this as cosine of 52. So 1 divided by cosine of 52 would give me 1.6243. Now, the next two are in radian mode, so we're going to press mode on our calculator and make sure radian is highlighted this time. And cosecant is not a button that's directly on my calculator, so I have to write this as in terms of sine. Cosecant's the reciprocal of sine. So we'll do 1 divided by sine of 5 radians. And that is negative 0.2 1.0428. And then finally, tangent of 3 radians. Just press tangent of 3. And that is negative 0.1425. And that's all there is to it. The next thing I want to do is I'd like to find an angle whose just doesn't fall nicely on the unit circle. None of the coordinates that we know will give us a tangent of 0.564, negative or positive. So we're going to start this process very much like we have been doing up to this point by finding our reference angle. Our reference angle we're going to find with the calculator this time. So we'll do inverse tangent, and we're going to do it of the positive 0.564. Because that's what will give us our reference angle. And notice that I want my answer to be in degrees. So when I pull up my calculator, I'm going to switch my calculator to degree mode by pressing the mode and highlighting degree. And now we'll do second tangent. That's how I get the inverse tangent of 0.564. Notice it's of the positive. That's what will give me my reference angle. My reference angle is 29.4. Now, looking at tangent, it is negative, which means that I'm going to have an answer where tangent is negative in the second quadrant and also in the fourth quadrant. So I'll have an answer in the second with a reference angle of 29.4 and also in the fourth with a reference angle of 29.4. So my first angle will be 180 minus 29.4, and my next angle, my next solution, will be 360 minus 29.4. So that's 180 minus 29.4. That's 150.6. And my next solution will be 360 minus the 29.4. And that's 330.6. So two answers, 150.6 and 330.6. We're going to do another one together. Again in degree mode. This time it says cosine of x is 0.421. So again, we're going to start by finding our reference angle. Our reference angle we get by doing inverse cosine of the positive ratio. In this case, it already is positive. But if it were negative, we would do the positive to get our reference angle. So again, we want our calculator in degree mode. Mine already is. So we'll do second cosine of 0.421. So my reference angle is 65.1 degrees. Now, cosine is positive. Therefore, I know that I'm going to have answers where cosine's positive. Cosine's positive in 1 and in 4. So I'm going to have answers in 1 and 4, both with 65.1 degree as my reference angle. So my first answer will be 65.1 because in the first quadrant, that is, the angle is the reference angle. And in the fourth quadrant, it'll be 360 minus 65.1. And that is 294.9 degrees. So two answers, 65.1 and 294.9. I'd like you to give this one a try. Press pause on your video, and when you're ready for the answer, press play again. So, sine of x is 3/4. Therefore, I find my reference angle by doing inverse sine of 3/4. That gives me 48.6. Sine is positive, so I know I have an answer in the first and also in the second quadrants. So my first answer is 48.6. my next answer is 180 minus 48.6. And that gives me two answers, 48.6 and 181.4. Okay, we're going to try this one together. You'll notice it's cosecant, and I don't readily have a button on my calculator to find the reference angle for that one. The other thing you're going to notice is this time I'm in radian mode. So before I find the reference angle, I have to write this in terms of sine. I know cosecant is 1 over sine of x. So sine of x has to be 1 over 2.143. So we'll work on finding the reference angle. My reference angle is going to be inverse sine of 1 over 2.143. So pulling up my calculator, first thing I have to do is put my calculator back in radian mode, and we'll do second sine, that's inverse sine, of 1 divided by 2.143. And I find that my reference angle is 0.49 radians. Now, you'll notice that cosecant's positive, sine's positive, so I'm going to have solutions in quadrants where sine is positive. That is in the first and the second quadrant, so I'm going to draw them. One over here, one over there, both with 0.49 radians. So two answers, x equals 0.49 radians, because in the first quadrant, the angle is the reference angle. In the second quadrant, it's going to be pi minus 0.49 radians. So second, and then the caret button. Caret button is right over there, minus 0.49. So that would be 2.65 radians. Two answers, 0.49 radians and 0.265 radians. You don't have to put the R there. I just do, just to remind me that we're dealing with radians. Okay, I'd like you to give this one a try. Press pause on your video. When you're ready for the answer, press play again. Okay, so we started. We needed to find the angles where cotangent of x was negative 5.147. We were dealing in radian mode because my constraint was in radians. So I had to change that to be in terms of tangent. So tangent and cotangent are reciprocals of each other. So I know tangent of x is 1 over negative 5.147. And I found the reference angle. My reference angle was inverse tangent of the positive ratio. And I got my reference angle to be 0.19 radians. Since tangent's negative, I know my solutions are in quadrants 2 and quadrants 4. So my first answer is pi minus 0.19, that's 2.95. And my second answer is 2 pi minus 0.195, 6.09. So two answers to that problem. So I'd like you to give your assignment a try. It's posted online. Have a great day.